So we're talking about imaginary numbers today, and in some of our previous problems we've had questions that look like this, like the square root of -4, and the square root of 4 is 2, and when we square root a negative you get an I, and it's plus or minus, right, when we square root when we're solving. So here we just want to simplify these, and so today's goal is I can use imaginary numbers, and that's through adding, subtracting, multiplying, and all that kind of stuff. I can also use the equation of a circle. Those are the learning goals today. Our essential question. So the square root of 50 negative is I, and we're just going to talk about positives today because we're not solving. 50, I50. And the square root of 50 we can't take, but let's look at all the ways we can get 50. So 50 is 1 and 50, and we're just doing positives today. 2 and 25, not 3, 4, and a decimal, so that's not going to work, 5 and 10. So 50 doesn't have too many combinations here, and that's okay. So in here, so when we look at square roots, we're going to simplify them, meaning that is there a pair that has a number we can square root? So we're going to do that square root. That's what we're looking for here. So we look at 5 and 10. That has nothing we can square root in it. 1 and 50 has nothing we can square root in it. But 2 and 25 does. So we have I. I'm going to write the number I can square root first, and the other number 2, because 2 times 25 is 50. Square root of 25 is 5, so we get 5i on the outside, root 2 on the inside. That's how we simplify our radicals, is what it's called, but we're dealing with imaginary numbers. -48 is no different. We can make a list of this. Many students get really good at this. Again, we're not going to worry about the negative because it'll come out as an I. 1 and 48, 2 and 24, 3 and 16, 4 and 12. Now 1 and 48 is gone. Same 2 and 24, because neither of those we can square root. We can square root 16 and we can square root 4. So we always pick the larger number. So I'm going to pick 3 and 16. So the square root of 16, square root of 3, and the negative is going to come out as an I. Square root of 16 is 4, and we get root 3. So on question number 3, we're just doing like terms. That's all. So we have a 5 and a -8, make -3, and then we'll switch colors here. -2i and 11i make 9i, and we have the answer. Here we're subtracting. So notice up here, I just want to emphasize this, it says addition or add. Okay, this right here says subtract. Now many students get this wrong. So what I tell students to do is to distribute the subtraction sign and change it to a plus. And then bring down the other number. And that'll help fix our mistake because we're subtracting both of those terms. And so if we distribute the negative and then put a plus there instead, then we're effectively doing that. Then we just do like terms. So we get -12 and 7i. We're done. That's it. You can't put those together. This right here is called a complex number, whereas this I is called an imaginary. So you might read these terms on an SAT. So make sure you understand complex number has, they call it they call it A plus BI. That's what they call it a lot of times, meaning that we have a number and then a number with an imaginary. So a complex number, we have two terms. Imaginary is just the I itself. Here we have a question here. Notice there's no add and subtract, so this is going to be FOIL. Okay? Notice i's act just like x's, except there's one exception, and I'll show you that here on this one. So first is 2 times 4 is 8. Then 2 times 6 is 12i. Negative 3i times 4 is negative 12i. Oh, so we got lucky. Same numbers. And then negative 3 times 6 is negative 18i squared. So what I always do is I always put the like terms in the middle. We get lucky this time, so that's 0. Not always 0. And then we have this I squared. I squared is equal to negative 1. So whenever we see an I squared, we put a negative 1. So we're going to get 8 minus 18 times negative 1, which turns into plus 18, which is 26. So we take something with a bunch of i's in it and times it all out, and we get a normal number. And that's how imaginary numbers are used in real life, is because sometimes when we have two combinations of imaginary numbers coming in, we actually have a regular number coming out. They use that in radio waves a lot and electronics. So this one here, we know that I squared is negative 1. And so we have 6i to the 10th. Now, isn't I squared the same as, aren't these the same? I squared to the 5th power. Is that the same as I to the 10th? And isn't I squared to the 2nd power the same as I to the 4th? Can you kind of see what I'm doing here? Because now we have 6 to the negative 1 plus 2 to the negative 1 with a power of 5 and a power of 2. Then now we can compute this. We have 5 negative 1s. Negative 1 times negative 1 times negative 1 times negative 1 times negative 1. Well, this is positive, a negative, so it's negative 6. Plus a negative times negative is positive, so it would be 2, so the answer is negative 4. Again, we have an example of imaginary numbers, yet we come out with a regular answer. So this is a question about circles. All right. And what we need to understand is how to graph circles, because notice we have these squares here. And we learned that last time. And then this is how you're going to see these on SAT most likely. Most likely if they're going to have you complete the square, it's going to be in a circle question. So in question 8, we're going to talk about that. On question 7, I just want to give you the basics. Okay? So on a circle, we have a center, right? This is a center, and it has a radius. Okay? So the center follows the same thing as our movements. So this movement is plus 5, but remember x is opposite, right? So we're going to go left 5. This one right here is opposite as well. So now y is opposite. It is also in parentheses, so I guess that makes sense. Y is opposite, so instead of going up, we're going to go down. Okay? And then this right here, the square root of that number of 16 is the radius. So the radius is 4. So now we can do this. So we can go left 5, down 2. 1, 2, 3, 4, 5. 1, 2. And we have the center of our circle. Now the radius is 4. So that means that we have 4 in every direction. So 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. And then we can draw the circle that is made by all these radii so that we count it. The radius is the radii. And that's our circle. Sweet. So this is what we learned last time a little bit. So now we have background on the circles, that we have the radius here is 4. And that means if we want to answer this question right, we need to find the diameter. So the diameter is 8. Okay. Next, we're going to actually use complete the square. So I just want to show you, if I reorganize this, I have x squared plus 10x, and I have y squared minus 8y equals 8. And we're going to do complete the square. So remember, we take this term here, right, and we cut it in half. So we take 10 and divide it by 2 and square it. So we get 5 squared is 25. So we're going to add and subtract 25. So x squared plus 10x plus 25 minus 25. And then I'm going to do this one in green. Okay, so we're going to change this to green here. So y squared, so plus y squared, minus 8y, and then 8 divided 2 is 4, right? 8 divided 2 is 4. 4 squared is 16. So we're going to add and subtract 16, and that's going to equal 8. Okay, and then I'm going to tic-tac-toe this. So I get x, this is a tic-tac-toe in my head, x plus 5 squared plus, or minus 25 plus, now in tic-tac-toe that, y minus 4 squared minus 16 equals 8. So now we completed the square twice. Then this number we're going to add to the other side of the equal sign. Make sure you understand where your sides are. Same with the 16. So that these are going to cancel and these are going to cancel. And then we're left with the equation of the circle that we started with in the first question. 8 plus 25 plus 16 is 49. Then we can graph this. So this is left 5, and this is up 4. Because remember, these are opposites, both of them now. And then the square root of 49 is 7. And that's the radius, which makes the diameter 14. And then on the SAT, they may ask you to graph. They may ask for the radius. They may ask for the diameter. They may ask for this stuff as well. So left 5, 1, 2, 3, 4, 5. Up 4, 1, 2, 3, 4. We have a dot. This is negative 5, comma 4. The SAT sometimes asks for that. Sometimes they ask for the radius, which is 7. So I'm going to count 7 each direction. That's 7 there. Here's 7. I'm going to estimate on these. Then we're going to draw the circle. Okay, so on the SAT, they can ask for any of this information, and a lot of it may be connected to complete the square to get our equation. Okay, so let me just show you again. If we go back to the first one, this is the equation, and these are both opposites. We're going left and down, and the square root of that is the radius. That's how we interpret this equation. It makes a circle shape. And then if we don't have that formula, notice this doesn't have it, we have to complete the square twice to get it. And then add. Okay. If you have any questions, let me know. I really wanted to go over this because this is technically supposed to be taught in geometry. But what I find out is no one learns it in geometry. So here we go. I just want to make sure you know how to do it so you can succeed. Have a good day.